think there's probably a little more food out there if you need seconds or thirds. Welcome to the afternoon session. Very excited to kick things off with Dr. Ray Levy, the Executive Director of North Carolina State's Data Science and AI Academy, newly renamed. Ray's an NC State Professor of Mathematics and a Fellow of the Society for Industrial and Applied Mathematics. Come on up, please. And Ray, are you introducing the speakers or am I?
We're all coming up.
Okay, great. Please join me in welcoming Ray and the panel.
Excuse us. Thank you.
All right, let's pull our chairs up a tiny bit without falling off so that we can actually see everyone here. All right.
Hello. Oh, better. Okay. Hi, everybody. Great morning, right? Yeah, great opening talk, opportunities to see the students present their work, and then an opportunity to really break into those breakouts. So thanks to the organizers for really organizing a great set of opportunities. So welcome to the Business and Industry Roundtable for lunch. We have 4 fantastic panelists that are going to introduce themselves. I'm Ray Levy from the Data Science and AI Academy as of yesterday. And we are in year 4. And I just wanted to say our purpose at NC State is to work across all colleges to really catalyze and network data science and AI and make sure that it's happening everywhere at NC State as well as possible. And then beyond that in North Carolina, nationally and globally. And NC State has a really long tradition of strength in these areas, and we continue to grow it in an interdisciplinary way. And the College of Engineering is really a leader. So thank you for that. All right, so here's what we're going to start with. Please introduce yourselves and share one thing that has changed in the last 6 months about your work life due to advancements in AI. Oh, click once till it's green. Yep.
Take 2. Okay, great. I'm Matt Hicks. I'm the CEO of Red Hat. And something that has changed for me in the last 6 months is I don't have a lot of time. I grew up as a product engineer, a programmer. With the advent of open source models and coding models and that, I'm actually able to take on a lot of tasks myself, programming them, that I probably wouldn't do anymore. So that's been really empowering to be able to do that, shape it a little bit, and be incredibly productive doing that for a while.
So you're saying you're getting your hands a little dirtier.
I am.
Than you would have
It's
anticipated.
been really enjoyable. I don't get to do that.
That's really cool.
John.
I'm John Petitte. I'm the co-founder and CEO of Amplifi Labs, which helps other companies build software. Over the last 6 months, there's been a huge impact on my team, which is international. And it can span anything from them using the technology to converse more effectively with customers and other individuals in English, to me, very similar to Matt, writing code again, and just to run some experiments and test some things out, to figuring out how do we more effectively and more quickly plan projects and that type of work. So it's been pretty massive. Thank you.
So how close are we to having that universal translator in our ear?
Honestly, pretty close. So I'm conversational in Japanese, but I've gotten to the point where when I send a message to my friends in Japan, I just put it in English, translate to Japanese, and send both, and they can read whatever they like, because it's just better than I am right now.
That's amazing.
Hi everyone. I'm Ozzy Lozoya. I graduated from BME in 2011. Hey, David. And I'm a scientific computing principal investigator at RTI. Most of our clients, well, almost exclusively all our clients are the federal government, primarily NIH. And so how has AI changed my work life? It's primarily trying to figure out the ins and outs of policy and how that impacts the ability of deploying AI for democratization of publicly funded science and clinical trial data.
Is AI able to help you policy documents can be hundreds of pages long. Is it helping you navigate some of that, or are people still having to really comb through it?
So all of that is very much doable, but one of the big challenges is that essentially both from the White House perspective and from the public service perspective, being able to deploy AI tooling in government structures is a little more guardrailed, and we need to be creative because it usually involves privacy preservation concerns, which I think we're going to touch upon later. And so privacy protection and safeguarding of that data plays a big role in the way that AI tools need to be deployed in a regulated manner. And that's kind of like our bread and butter.
Hi, everyone. My name is Elif Balkas. I'm the CTO at Wolfspeed. I graduated from NC State. I think it was 2004 from the Material Science Department. It was a grad school. So, go Wolf. And then work at the Wolfspeed now, which is actually founded by the NC State graduates. So, what we do at Wolfspeed is we basically a power electronics company, semiconductor company. We make silicon carbide semiconductor materials, and then we build devices on them, and then we package them all the way into the modules. Our primary products that we're all excited nowadays is the electric battery, electric vehicles, and electrification of everything. What's fascinating for us about the use of the AI, I'm going to tell you a little bit about what we do. So the silicon carbide is a semiconductor. What we make is that our processes start with making that. And then making it, it takes like, you need to heat the furnaces up to 2,500 degrees. And if you imagine that this room is about 25 degrees, 2,500, 2,500 degrees is kind of halfway to the surface of the sun. And then we start our processing there. But in that environment, we are trying to make single crystals because that's what we need for the devices. And then all the way into the operating devices in nanometer scale size of defects impact the device performance. So what we've been very excited about, and we started to utilize AI technologies, and what the technology offers is basically detect those defects, but more importantly, kind of understand that where are they coming from. Because when you think about the 2,500 degrees furnace, it's the metrology, control of the furnace, and then measurement is very difficult. You can't just, you can't look at it. The welding temperature is 1,400 degrees, is 1,000 degrees lower than that. What AI actually provides us with the possibility of that predictive analysis, and then look at the differences. And more so recently, we started to use the generative AI to detect the defects and correlate them to device performance, but also give a feedback to the process. We're very excited as a company and at the science field to utilize.
That's interesting. I always think about how AI is inverting, in some senses, the scientific method, where you used to have a hypothesis and then collect data that was very specifically designed to answer a particular question. And now we're starting often with data that's very generally collected, maybe not even for the purpose of the question that you're asking, right? But then you do still need to generate the question, and then you start getting the analysis. Have some of those processes of your scientific process inverted due to AI?
Definitely. Some of the challenges is a very good question. So that we have very fundamental physicists that work in this process for a very long time. A lot of our knowledge so far is empirical, because a lot of our hypotheses, we may try to develop a theoretical formula, and then we apply it to empirical methods, and then we end up seeing that, it just doesn't work. And then you need to try it several times. You know how there is always this coefficient factor that is just figuring that out is a big challenge. But then now that it also helps with figuring out those patterns, and then what works, and then behavioral patterns into process.
That's so interesting. Okay, next question. This question is really about preparation of the workforce and really helping NC State think about that from both the education perspective and the research perspective as we partner with industry. So 1 to 2 years from now, what will your company perhaps have accomplished? What do you hope for your company to have accomplished with AI? And then thinking from that framework that you need our students to be graduating ready to help you do that, how can we prepare them to help to succeed in that accomplishment? And then also, from the research perspective, what's the research that we need to be doing as a university in order to advance science and innovation? Because sometimes we have a longer time scale of research than industry, so sometimes we can do things that you just can't afford to take the time to do in industry.
So for us at Red Hat, we're pretty laser focused on a domain within AI. So that for us is 1 to 2 years, I would hope now, sure. And that is having smaller, to like 7 to 10 billion parameter models that are open source that you can train on domain topics. That's sort of our role in life. I call them the omniscient models. They're really quite incredible, but they're exotic. You hit security, privacy challenges. They're very hard to run on premise. They're tough to change weights and training on, but they've proven the technology. So I'm like, I put them in that bucket of I appreciate them being there. For us, being able to demystify how this works to a large extent, that's what I grew up with in open source code. I think that's very important, that these things don't become a magic box, but instead you understand how pre-training works and you understand that you can alignment tune something. And I'm a big fan of, I run almost everything on my laptop at this point to show people I can turn Wi-Fi off and still use this tool on my laptop. That's sort of our goal with it. I think on the student side, it's really teaching the applicability of it. My advice would be, if you're a skeptic, there's no fighting it. Like, the horses have left the barn on that. And so if you shame people or you say they shouldn't use it, your students will still use it. They're just not going to tell you. I think it is much more, and I see this at work as well, to embrace it and teach people the limits, but then teach them how they can shape it as well. But that's sort of where we focus. That's our goal for the next couple of years.
Are there some research areas where you feel like you wish you could look into that, but you need a longer time scale, or you need a different kind of set of interdisciplinary, teams on it?
I think for us, and again, we're a unique area, so we focus on what can build durable open source contribution communities. I do not think pre-training is, you can build a community around it. It costs $100 million per train of the model. Starting from that, though, and then doing alignment training, that is a really big space. It's funny, you're talking about languages. For us, we don't even tackle languages. Like, you will not, if you use our technology, you will not be able to put another human language alignment tune that, even if you have a book. It just doesn't work at this point. But it's incredible at reading documents or optimizing RAG patterns or those things. So I do think there are research areas for us. We only focus on what can people contribute and share work and build on it around, and then what's financially within reach of universities and companies and those things, which puts us in the alignment training bucket.
Thank you.
So we work in the application layer, right? So that's where we do most of our engineering. With that in mind, in 2 years, we want to, let's just talk about our specific goals as a company. We've got another company that we've started where we want to completely change the way everything in the United States is imported into the country and goes through trade duty compliance, right? Which we think we can do with LLMs. Now, also within that application layer, thinking about students and the role that they play. To me, what I've seen is the most effective people at building applications with AI are individuals who are capable of communicating effectively to other human beings. So you can think of them as being good managers. You can think about it in the way that I believe Greg spoke about previously, which is you've got a different stack of technologies, and we used to think that it was JavaScript, right, that's at the top. Now we've got one on top of that that's an AI interface to that. The best people at that AI interface are just really good at communicating. They communicate details. They know what the other person needs to hear, the context they have, the context they don't have. And I mean, if you probably know that this is a real issue, but we go through internal training with our own team to get them to understand, hey, you put this into the AI does not understand this, doesn't understand that, doesn't know this, doesn't know that. You do, right? But the AI does not. So I never got that training, honestly, when I went to NC State. A lot of great things, but it is a huge gap in my opinion. And I think it's about to get bigger if students just come out the same way that they've been coming out, and then they're said, all right, go do this, right? Work with AI, make this happen. And they're suddenly going to learn how to work with people with a computer. Right? Good luck with that. So that's what
And I really like our emphasis right now at NC State on project-based and workforce relevant teaching and learning, because I do think those projects, sometimes they're team-based, sometimes they're individual, but there's always that communication piece. And there's always that thinking about the client, thinking about the end user, and then thinking about how to talk to them both and listen to them as well, so that you make sure you're delivering something that's relevant. So personally, I'm heavily invested in project-based teaching and learning, because I think, that's where you're going to be communicating in every step of the way, in the same kinds of ways you're going to have to do it in the workforce.
I would say think about an entire class on human interaction and persuasion, in my opinion.
So at RTI, one of the call it unique remits that we have is that it's essentially multidisciplinary to begin with. Like, I work in a group that interacts mostly with NIH, but we have branches that interact with other government agencies, and we also have a fraction of the organization that is sort of like a mini CRO or services like that, that is more in the for-profit or consulting angle, which means that the types of problems that we get are from very different, call it silos. And one of the things that we do in the center that I work at is we are essentially, call it an interdisciplinary connector. So many of us do data science, which is one of the tenets for AI, and call it testing AI readiness or machine readiness, as people will call it. But each of us has an actual, call it scientific upbringing that is different. We have people that are lawyers who happen to interact in the field. We have people that are engineers. We have people that are clinicians. We have people that are experts in R&D. So the flavor of problems that we get is always in the premise that in most environments, you get to a point in which an organization that is looking for your support already has a digital scaffold, but they don't necessarily know how to use it best, right? And so it becomes a question of deploying AI tools and doing the very human in the loop type of work of rallying support and lobbying for solutions that you need to essentially educate people about, right? And so in the concept of government, people have an appetite in every agency to do it, but there's also restrictions about privacy and about being able to confine that in a way that the data doesn't leak to external parties that may or may not have malicious intent. And so it changes the conversation, not on the merits of AI, but its trustworthiness. And that's one of the aspects that in many regards goes beyond the actual tool itself. It really deals with instilling in part of training a sense of judgment and a sense of regard for the technology as a tool that can amplify the inception of solutions, but are those the solutions that you believe are adequate to implement just because they are the best technically optimal?
So if you hired somebody yesterday, what's one thing you're pretty sure you didn't get that you were hoping you'd get in that hire with that regard? Yeah.
I don't think, particularly the concept of AI being, call it an equalizer for solution mining, an element of persuasion, because decision-making is still going to be human, and you still need to broker a solution with parties, particularly the bigger problems you get, the larger the teams will get, the more different upbringings you will face. And so being able to communicate across different types of vocabularies. Like I think we were talking earlier, like call it computer scientists will use terms that are familiar to them in their context, and they may be the exact same homonyms that somebody would use in another field, but they actually speak to different principles. And so the message can get distorted. And AI not necessarily solve that, call it cultural intersectionality. Humans have to do that, and that is not an innate ability. That
So
has to be
two
fostered.
votes for persuasion, I'm hearing.
Yes.
Two votes in our College of Humanities and Social Sciences, digital rhetoric, media, we've got strengths there. And so I think, again, thinking how our students across these disciplines can be not only getting those things in the other places, but also have the collaborations amongst professors to think about how we bring that across the curriculum is exciting.
Yeah, we, as an industry at Wolfspeed, in the power electronics industry, that we use what technology offers in terms of the AI. But when we think about the power electronics, it is being revolutionized with the silicon carbide technologies, and it's relatively still new compared to silicon-based power electronics technologies. And I think during the next 1 to 2 years that it's going to be, the trajectory is going to be very different compared to silicon because of these type of technologies. What we aim to at Wolfspeed, that it has like several aspects. Primarily what's interesting for us as a CTO and in my group, that the technology groups, that how do we utilize the AI-based technologies into the accelerated technology development. It's huge there. That's normally that we would plan an experiment and then we would run it, look at the results, but with the use of the algorithms and the simulation tools that we set it up, the algorithms overnight, and then when we come back, that it gives us, the several different, the scenarios. If you do this, and then you get this result. So it really accelerates the technology development. On the other hand, it also very accelerates the troubleshooting when we see an issue in the production environment. Pathfinding, and then looking at this, something is something is weird, and then go focus that it's very powerful. So when we think about the next couple of years, that also that one area that's very powerful, that the factory optimization utilizing the AI technology. So we're also very excited about that. So for us, it's very, very the diverse where we can take advantage of it. When it comes to technology part of it, that where we find that most useful in our groups, that the individuals putting the effort here, really that the individuals educated from the interdisciplinary programs, just like you're trying to create here, that the whether it's if it's in the materials, semiconductor materials group, that material science educated, but with the knowledge of the programming, that can take the open source and then build models utilizing those. So it has to be a combination. Maybe in the future that's going to change, that the decision-making part of it will be more and more embedded into the artificial intelligence. But today that we have to have an expert, even the creating those models and the algorithms. And then when you look at the the electronics part of it, the device design or the performance, we need the electric and computer science, that knowledge combined with the programming knowledge to kind of get the best out of all worlds. So it's really that very much interdisciplinary for us.
Yeah, and we're especially here excited about our new integrative sciences building, where we're going to have a whole floor of what we sometimes call self-driving labs. But I also really liked the ideas from the keynote, where we might think of ourselves as driving a ship, right? Making decisions. We're at the helm. So yes, we don't have to stay up all night. There might be things that can happen as we're getting tired, but we are still responsible for the decisions. We also have a new AI ethics center. We were just funded by the National Endowment from the Humanities for one of 5 centers nationwide, out of a competition of about 100 institutions. So we're super excited also to be able to combine the ethical issues, which leads to our next question. So many concerns you've raised: security, privacy, as some of the issues that are coming up with AI. What are your concerns. So I'll give you a list. Are you worried about, so when I talk to the national labs, they're worried about power and water. They're just worried about, are we going to need nuclear power, for example, to power some of these training of the models? Are we going to have power that's competing with, say, your house or a hospital for power, right? Who's going to win in the usage of power if you're going to bid on the energy usage because you need to train your models? Okay, so that's one. There's privacy. There's also concerns about people being manipulatable. So on the positive side, we have marketing where we try to adjust people's behavior to purchase certain things. But we also know that if you have enough data, you might be able to nudge people, right? And so now you can nudge and nudge and nudge people and influence people. So these are some of the things. We also, in the keynote, heard about bias being an important thing, a positive thing. Little b bias, you want your model to do the things you want it to do. You want to bias it to do what you care about. But we also know there are human biases that you may not prefer, and you need to train those out of the model. So of all of those kinds of things, the question is, how can academia and industry partner to address what might be the new grand challenges, which are addressing some of these issues that may or may not have financial incentives directly connected to them? So question number one, what are you most concerned about? And question number two, how might we partner to address a concern like that?
Yeah, so for myself, being in the small model camp, I think the nuclear reactor debate is somewhere between ridiculous and over scope. Now, if you're trying to train 2 trillion parameter models all the time, every day, absolutely. But if we get good at that incremental training of small models in domains, it's not a nuclear reactor science problem. This is a 4-way or 8-way GPU box. And they are power dense, but they're going to run in the data center or colo that you know and love today. But I think it's important to be able to take that off the table and say this is something that's not going to change national security from a power consumption perspective and be incredibly effective. As in, like in most cases that we work with, their scope domains, you'll beat GPT-4 with the trained outcomes of these. And so that's I think, a passionate area. The thing I worry about is opaque data going into users' hands. If you think about my space, it revolves around trademark and copyright law in open source. That's essentially the foundation of it, and then you attach those to licenses, and you have to respect that to be able to share. There are lots of different licenses. When you make that opaque, the whole system breaks down. And so small models is a neat technology, no worries about power there, but having the data affinity, say I understand the provenance of what I'm working with, and I understand if this is a novel work, an output, or if it's a copyright tie, and that's going to require the license I must choose, and there are implications to that. That is an area where there are not a lot of open data models on the market right now, and I think that is will be a bit hard to sustain in software.
So I do have a suspicion that our use of AI is going to require more and more energy, and maybe it's a little bit selfish that I believe that, because who knows the only university campus that has a nuclear reactor in the United States? Yeah, exactly, NC State. So I think that there's a unique opportunity there for NC State to potentially take the lead on specific aspects of research. So just a side note, I think that's pretty cool. From a security standpoint, in terms of, I think you mentioned, creating fake things, right? I suspect there's going to have to be a mental shift, a mental revolution, probably equivalent to the campaign against smoking, that trains people to just don't believe everything that you see on the internet, to be honest with you. I don't see how anything other than that level of effort is going to produce the type of mentality that's required. I think regulation is possible, might solve some of it, but honestly, I think regulation is probably going to put a big cap on the open source industry and community, which is very important to me. And I can talk about that a little bit more later, but that's kind of what I expect is going to end up happening if we want to solve that issue.
Yeah, we've been thinking about that a lot. There's a great saying, I'm not an electrician. I don't know how electricity works, but I know not to put a fork in the light socket, right? And I know not to dry my hair, in the shower, etc. And so we've been really thinking about what are those equivalents, right? So one of them is don't believe everything you see, hear, read, whatever, but beyond that, right? Like how do we start thinking about what are those clever messages that we might be able to change public behaviors or thoughts or actions, so I think that is a grand challenge because we know humans like stories. So what's the story that we're going to tell that helps humans now believe that they shouldn't just believe?
And to loop back to persuasion, the first step is teaching people how it works. If they can do it themselves, then it's easier to recognize it.
Yeah, so in terms of resource allocation to run these models, well, I have bias. I have my two own perspectives. So the first one is, it's almost like in golf. You go with what you have, right? So, we can create new platforms to provide energy, but in the interim, there's only so much that we can devote for, AI foundational model building, which means until that possibility, we just have to become more efficient, and that's going to dictate what types of algorithms are put in and what type of data we fill them with. It also speaks about parsimony, which means you can have all the data, and this is one of the problems that is almost commonplace to biology right now. 20 years ago, you could devote a big chunk of your career to one or two molecules because there wasn't enough information to be had at the same time. Now, in every experiment, you get more data that you can mine in a lifetime. You just have to make a choice. And so there is an inherent principle that means your models are to be useful, but they are not expected to be entirely comprehensive and call it mechanistic. Like you can only do so much with analysis paralysis. You have to get action going, and so your models will respond to the need to come up with answers and solutions to the pace of when you make decisions. So that's one end. In terms of things that may concern me, at least in my circle of influence and my line of work, the main tenet is that I try to convey is that there is a difference between who's the client and who's the customer. And so being able to understand that difference means that the responsible or ethical choices you can make in terms of developing solutions around AI allow you to have some level of restraint to say this solution may be the best technically, but it's not the most adequate for the recipients of the benefits or the hurt that they can bring. Can you create a solution that stigmatizes certain populations? Well, maybe not a good idea, even though it's probably the most optimal solution. And so that's kind of like the philosophy. Like we as professionals have someone to deliver a product to, but that's not always the persons that the solution impacts directly. And so having that awareness only comes with expertise and exposure to the professional environment, not just the technology. And so that's an important tenet of how to think about AI in a responsible manner, at least in my view.
Thank you.
Thank you. So I'll start, since I keep saying that we're the user of the technology, so I'll start from how we are concerned about the security in our workplace. So we generate a lot of data. We generate kind of like our own big data. And then for our industries, data is kind of like the new oil. So it's extremely valuable for our competitors and then, the nationwide and all that. So security of the data, as we generate more, it gives us more of a concern that how do we keep it, the contained and secured. And as we develop these algorithms to make decisions, pattern finding, to help us with the accelerated technology development, again, that how do we keep that secure? That is a concern for us. But dealing with those type of things, so it's for us to working with our IT teams and also the programmers. So it's a big effort there to keep it secure at the same time. But also, I want to touch on the energy aspect of it, since we are in the power electronics, and then I'm very closely monitoring this, because one of our big applications for the growing and for the future is the data centers. And then we know that based on how it's going, currently in United States, about the couple of % of the total electricity is used for the data centers. That is expected to go up about 9 to 10% in 2030. It's huge. Then the major topic is that we're going to have a grid problem. How are we going to have the electricity for all those? So that, but then it comes back to full circle for us. The interest for Wolfspeed is that it's going to be all about efficiencies, energy efficiencies. How do we use the energy efficiently? And I believe there's the same considerations for the data on the computation, the chip design and the computation power, that how do you make those, the hardware side of things more efficient. So it kind of creates the whole ecosystem for itself. But when it comes to the use of the AI, my personal opinion that I think we will have to have some policies and the regulations that in terms of the use of the AI, when it comes to the nefarious activities, deepfake, and then how the use of it in the marketing activities, and when you sell it, even it all happens to all of us, that the airplane tickets, the predicting that what the next move for a person, that in when you're in a rush and when you're in a the desperation and taking advantage of it, those type of things that needs to be regulated, and there should be some rules around it. That's my personal opinion there.
All right, we're going to do a lightning round. And then, audience, you're going to get to ask some questions. So you can think, do you have a question you want to ask? And then we're going to take a picture. So, Jim, come up here and we'll get a picture after. Okay, so what are you super excited about? We're going to end on a positive note. I am super excited about personalized medicine. When I am, assigned a drug and a dosage, I want it to be for me. I don't want it to be the take 2 aspirin, call me in the morning version. I want something, and I want it to get tuned. I want them to be doing my labs, and then I want them to say, okay, don't take that dosage. I think let's do the next dosage. Right now, it's like you do that dosage till you go back to the doctor and ask for a different dosage, right? But I'd like to be monitored. So I'm interested in wearables. We're really strong with wearables here, right, as this center and colleagues. And so, lots of opportunities here to think about personalized medicine. What are you super excited about? Lightning round, and then audience, get your questions ready.
So I'm super excited about, I'm an optimist. I see it in open source all the time, but just the impact of an individual on it. In software, we'd say it's like 100x between the number 1 person and, say, the number 10. And I have a worldwide scoreboard. I can go look and see who is number 1, 2, 3, 4, 5 on projects. One thing that keeps number 1s from happening in a lot of cases is just this toil and inefficiency of all the other stuff we make people do. I am very excited, but just what I experience is the impact of taking away this toil. I'm hoping we'll see that unique human creativity and a lot more volume that can flourish and actually happen. So excited to see what that leads to.
I think an artist went viral saying, I don't want AI to do my art so I can do my laundry and my dishes. Yeah. I want AI to do my laundry and my dishes so I can do my art. And I think you're in some sense, echoing that sentiment. Love it.
I'm going to be an engineer here for a moment. I'm going to cozy up to Matt a little bit and say I am most excited about the role of open source in the current wave. I think a lot of that momentum transferred over from the blockchain era, where everybody saw, hey, I can just get in this. And I think that's happening similarly here. And to be perfectly frank, like application layer work, which is huge portion of the work that's done is built on open source. I mean, from the programming language to the framework to the tool you use to build it to the operating system you deploy on, it's literally everywhere. And the amount of human effort, the amount of turnover in technology, the amount of changes and just, tumult taking place in the open source world right now to do cool things is going to produce so much value. It's going to be crazy. I mean, that to me is the most exciting because everything else we're going to be building on top of that. 100% we will be.
Yeah, so I'm going to second the precision medicine and personalized medicine because, of course. But something that I find really exciting, and it's probably kind of an umbrella to that, is hyperlocal community resilience, in the sense that different communities, geographically, whatever, they have faced similar problems and they have found solutions, but the next community may not be aware of them. And so that would allow to democratize access to ways to keep communities safe for whatever types of exposures or risk, whether they're environmental, social, or what have you. One of the benefits of AI is that I think I commented this earlier. It's a way to commodify trial and error for better lessons learned by somebody else that we may not know, so that we can use that and benefit from them. And so we can do that at community levels. We can make communities, they may not know that two communities are sisters because they're sharing similar problems, but they can have access to solutions that benefit both if their problems are significantly similar. And so we can imagine that we can scale that to call it food insecurity, or we can do that for healthcare, or we can do that through digital twins for disaster surveillance and things like that. I mean, that needs to be done really fast, and AI may just be the platform that allows that to be done at the push of a button in a smartphone or in an interface that some government agency or some individual can benefit from.
That's really interesting because in the morning we were talking about crashing rockets, right? And how do we get students to feel like it's okay to fail? How do we as instructors not give them an F when they seem to fail to us if we're supposed to be encouraging them to fail big? How do we think about that? And I was thinking about, as professors, we have to publish results that are something positive, and we always joke about what we really need to be publishing is our failures so that no one else goes down that same rabbit hole and tries it again. And so you make me wonder, how do we build the information about the failures into the AI so that you're not only building off other people's successes to have more community hyperlocal resilience, but also how do we encourage the communication of the failures so that we also are not replicating those failures in every team because we didn't tell each other, that actually didn't work. So I don't know, that's maybe something that academia could work on, right? Because again, it's all about our incentive structures that dissuade us from, even on social media, saying, I tried this and it didn't work, so y'all just don't do that.
Yeah, in my personal opinion, that I agree that the open source aspect of it it was the most powerful, I think, to having creating actually today all this excitement because it becomes accessible to pretty much every area. It allows us as Wolfspeed to use what technology offers. So I think it's super exciting, that part has to stay that way. And then that there's so much, the excitement that you basically don't know where to begin with. We're talking about from personal to how we can use it in the technology. Based on what I was, I'm also fascinated by the history of the AI as we were putting our efforts looking at the history, that how actually observing how the brain functions, the early ons, and then creating those neural networks. And then, but I'll touch on the energy aspect of it again, that those signals becoming digital, but then more so recently having the realization that if you mix signals with the digital to analog, that you're more effective and then you're more successful. I'm most fascinated or excited about the as we improve or develop the AI-based technologies, we will understand our brain functions and the brain possibilities more, and it's going to open up new horizons in terms of our cognitive functions. And then kind of similar to what you're saying, that having the routine jobs to be done by the AI, and then allow ourselves to kind of like to open up the new horizons and then go reach out to the next thing.
I know, I kept saying, well, if AI is going to take my job, it could definitely take like a day of my job, and we could have 3-day weekends, and I would be really okay with that, right? I mean, I think we need to envision the futures. Why are we doing this, right? And then how do we really advocate for the future that we want, so that we can do our art or our cooking or play with our grandchildren or whatever it is we love to do. All right, audience, we have a few minutes for you to ask your questions. We've got an amazing panel here, so here's your chance.
If I may add one thing.
Yes, and should I run around with this mic, or is there a person to run around with a mic? What is your suggestion? And so I will maybe start running around while you're talking. Okay.
Yeah, so I think that in terms of how this impacts academic research and all of that, I think we have to already start thinking of getting used to the idea that Greg put it really well. The technology life cycle is 2 years or less. That's usually the time it takes to write a manuscript and get it accepted, at least, which means the reward incentives are intrinsically going to change. If it's going to be publishing articles, then whatever you publish is already obsolete. So is that the mechanism to assess productivity, performance, or stature to begin with, when the incentives to do technology through AI and performance augmentation are moving at a much faster pace than our ability to communicate it? And so that is a larger, more immediate question that I would have. And I don't think there's a good or bad answer to it yet. We just need to try different incentive methods and different incentive mechanisms, because the ones we have right now are not going to work.
Interdisciplinary incentives are also challenging.
I think we have the first question over here.
Thank you so much for the great panel. My name is Sina from CB department. So I think the 4 presenters mentioned about we need a training session for the employees for each group of the company. So I'm thinking about, I want to ask about your perspective for the future. So each of us has a different skills, and I'm thinking about 2 ways in future. One way could be hiring one specialist in AI in each group in the company, or do you think that the company needs to train everyone in the company? So based on the budget and the decision making, I think it would be completely different. But I think if we want to use AI in both upstream and downstream of the company, we need to have a knowledge to use the AI. It's not just using AI to solve the issue. Thank you.
So for us, I'd say everybody is going to need to be trained with how to interact with like the application layer, so just interacting with the AI. If you're talking about lower level, building in it, etc., we don't really operate in that space. We don't need anyone there. So if you're going to go to that level, I think we want to make sure that everybody's aware, when they're working in that, okay, these are the places you're going to end up, right? Like, for example, Fox, right? They're working an application layer. They're not working that lower level. So you're not going to go work for Fox. You're going to go work for somebody else. So I think as long as students and individuals understand the routes that are the consequences of the different skill sets they have, I think that would be sufficient for what I see.
So for me, part of my job, I get to talk to all of a lot of our new hire associates on it. And it's on one side, it's a turbulent time. I think they're trying to figure out, what do they put their time into that's durable for a career? And it feels like there won't be anything durable. On the other side, my advice to them is, you're coming into a profession where you can learn how to wield this technology to amplify you and what you want to build your career on. And by doing that, you're going to outcompete a lot of other people, even in our own company, that are just hesitant to picking up that new skill. Like they're curious. And so for me, my expectation is similar to John's. Like every person in the company will need to learn how to interact and use these to make themselves more impactful. I do think the earlier career demographics has a natural advantage because they haven't seen as many failures as someone like me might have, to where I might just not try it. And they will try it, and they will have new tools to try it and guide them. And so that has sort of been my guidance to them, is like, own this, embrace it, because it can really amplify what you can do faster.
Yeah, I think I have a more practical view in it, I guess. There are people who have to worry about implementation of AI security, how to, remove inadvertent bias and things like that. But I also want to think in the context of, somebody asked earlier, about a model. Greg was speaking about this optimization model, and it's like, well, he did it in his laptop. And then they asked, well, but did they really do it in their laptop, right? Like he had to go to a cloud and things. And in a way, it sounds familiar to essentially driving a car, right? For you to drive a car, many things have to fall into place, right? And now you get to just drive the car, and you don't have to think about many of those things at once. Like, I don't need to learn how to lay tar to make asphalt to drive a car. It's implied that infrastructure exists, and somebody has to take care of that. And so in a way, talking about AI is not talking about how do I implement this tool for my purposes. It's more understand that AI is another element in an ecosystem of performance augmentation. And so whether you want to use it or not, it's going to happen. It's already happening. And it might just be the way that we're already using it in many ways, because it's dictating how we get advertisement, how do we do other things that we're just habituated to doing. But it really depends on where in that ecosystem you want to belong. Do you want to be part of the people that find the ways to, call it, sheepdog the technology, or are you just interested in the benefits of it? And that's dictated by what you envision in your career to do, and that's going to dictate the type of training you need to get. But make no mistake, this is here, it's already being used, and we're just along for the ride in many ways.
Yes, from my personal experience, that you have to be educated at least to be relevant, to stay relevant, right? That whether you're the user of it or the developer of it in any type of industry, company, I think in this time frame, and then the future is only going to be more utilizing the AI technologies. Specifically for our company, that we have the technology groups. There we utilize the data scientists and interdisciplinary individuals to develop what we call technology. Whether it's a tool, whether it's an algorithm, sometimes a combination of it. But for us, it's powerful when we implement, so we almost always want to put it in the production environment. So there, if you're, the career aspiration to be in that type of a production environment, you still need to know how it runs, to be able to troubleshoot or to understand what comes out of it to be relevant. So I only see that, that there's no returning back, and it's only going to get bigger and more useful and more versatile.
I was going to let one more question go.
Absolutely.
The panelists to be brief in their response.
Yes. Okay. Thanks, Jim. So I'm Muninder Singh from computer science. My question is, I was going to have a long-winded introduction, which is that I think innovations usually come from the corners, like the small disruptions. And I was wondering, if you have thoughts about it. Of course, you mentioned small models and you mentioned AI regulation. But are there other such challenges that you can pose to the research community? Or opportunities that you see that you can pose to the research community?
I mean, for me, I think Ozzy touched on a really important aspect. 2 years, I would say, is is quite conservative in our cycle. Openly, like we just made generally available, we serve pretty big customers conservative with Rel AI. That started in February for us. So a company our size, like multi-billion-dollar company, we're pushing this to like a 6-month life cycle in a very conservative space. So I think tons of research topics, areas. It's that time frame compression that is the key thing. Otherwise, we don't get to use the research because it's too slow.
I would just like to emphasize that in the world of software, we're talking, could be months, right, or less. In our layer of software, we called it JavaScript fatigue, where literally like every 30 days, a new framework, a new platform, a new tool would come out, and it'd be good at something, and then you spend the next month figuring out what it's good for, and then the next one comes out, and you actually didn't get any work done because you were just learning what the tools are. So that's probably going to continue, and I think the rest of the industry, not just the software world, is going to suddenly get a taste of what that's like, which is going to be very, very challenging and probably traumatizing for a number of people until you get accustomed to it and you get accustomed to making the decision like, I don't know what that does and I don't care. I'm just going to use this. All right. It won't exist in 2 months, right? I'll care about this next thing. So it'll be a mental acclimation.
Yeah, so fields of research, I can think of two. One very close to this College of Engineering, digital engineering. It's an obvious one. Essentially decentralizing the ability of designing products because you're able to create digital twins digitally that perform, if not as well as having built a prototype, very close to it. So that way you can decentralize that talent and not have it to be physically located in a plant or in a facility. That also allows you to get larger teams involved into designing and fail-safing a product. So that's one. So that's more like manufacturing, for example. The other one is ontologies or data models, which is to say there's a lot of data, but it's very loosely organized, which means the only way that you make an AI tool very powerful is to what extent are you able to organize it in a, call it somehow consilient way across different sources of information. It's a classic problem in biomedical and biological sciences that everybody represents their data in their own familiar taste. And when you try to reuse it across different studies, it's very hard because nobody had a standard to follow. And it's not unique to biology. So creating ways to take raw data and shoehorn it into a usable standard is the first step to create a tool that can actually be powerful. Without that synchronization, it is very difficult.
Since we are in the semiconductor hardware side of things, that our research cycles and the product cycles are about 16 months to 18 months, and I think that because of the the hardware side of it, it's going to stay that way. It may be a little shorter, but the way I think of it, because of the the use of the AI in technology development, every time in those cycles that the advancements will be greater. And I really think about it when we look at it in the larger scale, that really with the AI technologies, it also changes the trajectory of the whole, how overall power electronics is going to improve.
Can we thank our panelists?
Yeah, that's what I was going to say. Thank you very much to all panelists for your insights. And again, another round of applause for them. Oh, another one. Yeah, another one, a second one. And it was really interesting. There are a couple of points that stuck with me, that we have to make our students more insightful, give them the skills to be better communicators, make them more interdisciplinary, make them think about the ethical issues related when working with AI, and definitely teach them the art of persuasion when we work in this field. So thank you very much.